So we all should be on page 16. The last topic that we have not covered this chapter is what's called power of the test. So it's the last notes we need to take is power of the test. So we should probably start by talking about what it means when I say power. So the power of the test is the probability of correctly rejecting the null when the null is false. So if the null is false, you should reject it. So it's the probability when the null is false of making the correct decision to reject the null. Do you think then if you're carrying out a hypothesis test, do you want a high power of the test or a low power? High power, right? You want it to be more likely that you make the correct decision. So the way that you calculate power is you take 1 and you subtract the probability if the null is false of failing to reject the null. Now this should make sense. If the null is false, you should reject it. You shouldn't fail to reject it. So this is an error. So you're taking 1 and you're subtracting the probability of making the wrong decision. What is the probability of failing to reject the null if the null is false? Type 2 error is what I'm looking for. What is the symbol for a type 2 error? Beta. Okay, so what we are going to talk about in terms of power, we are going to talk about how to interpret power and how to change power. We're not actually going to calculate it though. So looking at the first example, a drug manufacturer has developed a new cholesterol-reducing medication that they think is better than its current drug. To test it, they recruit 100 volunteers and randomly assign half to the new drug and half to the old drug. When the experiment is over, they will conduct a significance test to determine if there is convincing evidence that the new drug is better than the current drug. Okay. So part A, we need to describe a type 1 and a type 2 error in context. What do we need to do before we describe a type 1 and a type 2 error? Bless you. Yeah, we need to know what the null and the alternative are. In this case, if we are looking at reducing cholesterol, what kind of parameter do you think we're talking about? Mu, right? We're probably going to calculate like the average cholesterol. So the null is that the average cholesterol for the people taking the new drug is the same as the average for the people taking the current drug. Alternative, again, is going to have mu of the new drug and then the average of the current drug. If the new drug is better than the current drug, what is going to be the inequality there? Less than, right? The average cholesterol for the new drug group is going to be lower. This is what we're going to do next chapter. So next chapter, we're going to look at 2 different samples, comparing them, just so you know what's coming up. Okay, type 1 error. Anyone? What a type 1 error in this context would be? Victoria?
You find evidence that the new drug is, like, the average for the new drug is less than the current drug when that's actually false.
Correct. So finding sufficient evidence that the new drug is, I'm just going to say, better than the current drug. When this is not the case. Type 2 error, you fail to reject the null, but the null is false. So in this case, we do not find sufficient evidence that the new drug is better than the current one. When it actually is. Okay, the reason that we needed to describe the type 2 error and type 1 error is to now be able to describe the power of the test. So power of the test is related to a type 2 error. So power of the test is the probability of correctly rejecting the null when the null is false. So in context, the power of the test is the probability of finding sufficient evidence that the new drug is more effective than the current when this is true. Okay, so that's the first thing that you need to be able to do is you need to be able to interpret power, or tell me what power means in context. Next thing you need to be able to do is tell me how we can increase power. We've already talked about you want a high power on your test. So there's 4 different ways that you can increase power. First way is that you increase the sample size. Now, why is that the case? If you take a bigger sample, you have more data, you are more likely to make the correct decision. So more data, you are more likely to make the correct decision. Second way has to do with alpha. So knowing that power is 1 minus beta, what would we have to do to alpha to increase the power? What do you guys think? Increase? Margot, why does it make sense to increase alpha?
Because they're inversely related.
Right. So, second way is you want to increase alpha. If you increase alpha, that'll in turn decrease beta. If you decrease beta, you have a higher power. Okay, these two are the most practical. The next one is not very practical at all. Okay, third way to increase power is that you can increase the difference between the null and what I'm going to call the true value. So let's say that our null is that mu equals 10, but we end up rejecting the null because mu is actually different than 10. The further away that the true mu gets from 10, the higher the power of the test will be. So if our null is that mu equals 10, power of the test will be higher if the true value of mu is 8 as compared to 9. With me. Why did I say this one is not practical?
You don't know the true value.
Yeah, you don't know the true value. So this one, highly impractical. Last way. This one is more practical. You are going to account for other sources of variability. Okay, This is going to be a throwback to chapter 4. When designing experiments, observational studies, surveys, what were some ways that you controlled sources of variability or controlled variables that might skew your results?
Randomizing to get rid of confounding variables.
Yep, randomizing. What else? Okay, you go. That's what I was looking for, blocking. And what goes along with blocking? What did you say?
Isn't that a thing too?
Are you saying chunking?
Yeah.
Like C-H-U-N-K? Chunking? That is not a stats word I've ever said.
I feel like I saw it recently, so like blocking and then something that starts with an S.
Stratifying.
Same thing, really.
Ariana, you got the blocking much faster than the other class did, though. So you get credit for that one. Okay, you have to calculate power before you collect data. Okay, next thing. I don't think we've talked about this before, but this is really important. Have we talked about the difference between statistical and practical significance? Do we know what statistical significance means? Okay, tell me what statistical significance means then, if we know what it means.
Fine.
Jackie.
It's like rare, so it would be like lower than alpha.
Okay, so statistical significance is when you reject the null. That means that your results are statistically significant. Okay, so we're going to do an example, or a quick thinking one. Let's say that you run a business where it is your business's job to fill up cans of whatever, cans of pop, cans of sparkling water, etc. You are assuming, if you're testing your equipment, that the mean is equal to 12, right? That on average, the cans are being filled up with the correct amount. Your alternative is going to be that mu is not equal to 12. So you're looking, is there evidence that the cans are being over or underfilled, that they're getting filled on average somewhere different than 12? If we reject the null, that means that the cans on average are not being filled the correct amount. Now, do we know what they're being filled? No. So what happens if they're actually being filled 12.01 fluid ounces? Do you care? Are you going to go through the process of buying all new machines or paying someone to fix them? Okay, this is a case where we have statistical significance because we rejected the null, but we do not have practical significance. So even though we had the evidence to reject the null, the difference to us doesn't really matter. Does that make sense? So even though you reject the null, it doesn't mean that the difference is big enough that you're going to care about it. With me? How would I find this number or estimate it? So how would I test for practical significance? Confidence interval. Yeah. So generally, when you reject the null, you follow up with a confidence interval, and that will give you an idea of how far off you are. Okay, what is the problem with carrying out multiple hypothesis tests? So what some people want to do is they want to collect one sample and carry out a whole bunch of different hypothesis tests. The issue is that each hypothesis test comes with error. So if you carry out multiple hypothesis tests, you're just compounding the error on top of itself. So problem of multiple tests, it compounds the error. Okay. The next page, I just let the other class go and try, and they kind of went down in flames. So I'm thinking it might be better if I start you out. So why don't I try to start you out, and then we'll see. Hopefully you guys get what you want. Okay. In the potato example, we didn't do the potato example, but I'm telling you what it is right now. The inspector is testing the null that p equals 0.08 versus p is greater than 0.08. Random sample of 500. P is the true proportion of blemished potatoes. So we want to know, is the true proportion of blemished potatoes 0.08 or greater than 0.08? Suppose that the true proportion of blemished potatoes is 0.1. Okay, this is the actual true proportion, but keep in mind, We never know that. So I'm just telling you now to illustrate the next point. What is the correct decision in this case? To reject the null or fail to reject the null? Reject. Why would we reject the null in this case? Correct. Because the true proportion, that 0.1, is greater than 0.08. You guys with me so far? So the true proportion we got, greater than 0.08, so we would want to reject the null. Okay. Would the inspector be more likely to find convincing evidence that P is greater than 0.08 if he looks at a small sample of potatoes or a large sample of potatoes? I wasn't ready yet, but yes, large. Here's what this question is asking. More likely to find convincing evidence. This is asking about rejecting the null. So are we more likely to reject the null if the null is false if we look at a small sample or a large sample? So this really, all of that is asking about power. So is your power higher if you have a small sample or a large sample? Definitely a large sample. If I asked you to explain, what would you say?
The larger sample increases power.
Yeah, both of those. Increases power, decreases variability, so you're more likely to make the correct decision. Okay. You try C, D, and E over the next, let's say, 5 minutes. You can work with the person next to you, of course.
I thought it's 0.10 because it's power. No.
Yeah. I don't know if it's asking for more convincing evidence, like that it's more convincing, or just like I think it's the point where because if it's much more related to 0.5, that's always more like 5, that's less like second shipment because first shipment or second shipment, right? Or no more than the weight value is lower than so it's like because further from tree values further away from the null.
So second
Increases
shipment.
the difference. Increase the sample size.
We already have that. The block is stratifying. We're not supposed to.
Go how far you think you can. Yeah.
So Adam would be 0.76 is the proper. Correct. Okay.
So 0.76 is 1 minus. Oh, so
Like when it says what's probably effective.
so this is type 1 error, so that means type 2 has to be 0.95.
Oh, yeah, probably.
So it would be 0.76 equals.
The probability of correctly rejecting HO equals 0.08 when it's false.
Yeah.
Sorry, okay.
Probability of correctly rejecting 0.08 when it's false.
So it's just kind of like interpreting. It's just interpreting it.
There's no, I don't see a different way to interpret power.
Oh.
This would say like,
Power equals 1 minus beta.
And then
beta is the probability.
I just meant just now.
And then so the probability is alpha.
Do we know the power?
I'm probably
Beta
guessing
is
the
what?
power is
that's is that probability of it?
Oh, the probability, so it's 1 minus 0.9. Yeah.
I thought it's 0 minus 0.76.
Wait, 1 minus 0.76?
Yeah? Because look,
Isn't
because it's fails to reject age or false. So that's a bait. That's type 2 error.
Is the probability
what is alpha? Like alpha is the...
So alpha can never be greater than 1. So 1 minus alpha.
Like I know 1 minus alpha is beta, but I don't know if that's the probability. I mean,
I think it is because
We'll see. This took the other class 42 minutes.
I was gonna say we seem to be ahead of the other class.
And we didn't actually finish this page. So I did not answer. Yes, exactly. Well, like I said, I didn't start them out in the beginning. I just let them go, and that went downhill real fast.
What happened? Like, what were they doing the whole time?
They just were very confused. So that was partially, obviously, my fault.
okay, so is alpha the probability of having a type 1 error? Okay. So alpha is the probability of having a type 1 error, so beta is the probability of having a type 2 error.
Yeah, so what minus
0.76.
No, that's what I don't get though. It should be, because that should be the same. Right, there's that, but then shouldn't it, instead of 0.76 is 1 minus.
alpha's a type 1 error.
No, because with power equals 1 minus beta, so you would put 0.76.
Although you're finding sufficient evidence over 8%.
You're looking for beta, and beta's in the formula, and you have the value.
Okay.
I just need
What?
I made a question.
Good for you. Okay, I would like to start going over this. So, part C, will the inspector be more likely to combine blah, 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 alpha 0.1 or 0.01? 0.1. So if you increase alpha, it'll decrease beta, which increases the power. Part D, what if P is 0.5 versus 0.1? 0.5. Okay, here's where things get tricky. Do we know why? Besides, I told you. Right, because it's further away. Grace?
Because then it'll increase the power because you're more likely to get a false sample because it's more rare.
Correct.
If I said that correctly.
Yes. I would like to draw us a picture, and I'm going to say right off the bat, some of us are not going to get it, and that's okay. I will never ask you to draw this picture or explain it again, but it will further explain D for us. This is where chaos ensued, okay? Just so we know. No, it's not a pretty picture. Okay. So, you all remember that when we carry out a hypothesis test, I have you draw a figure, and your figure is always centered at the null, where we assume that the sampling distribution is, yes? Okay, so in this case, this is where we're assuming that the sampling distribution is. We're assuming that it's at 0.08, centered at 0.08, yes? Okay, and then there's a certain cutoff where alpha is 0.05, and if we get any samples here, we're going to reject the null. So anything here is going to have a probability less than 0.05, so we would reject the null. With me so far? Okay, let's say that the true value is actually 0.1, which we don't know, and let's say 0.1 is there. This is really the distribution then. So this is where I think the distribution is. This is where it actually is. So I'm really taking samples here. Okay. These are all of the samples that I could take where I would fail to reject the null, which would be the wrong decision. So these are all of the samples where this is the true proportion, but I still fail to reject the null. Now, if the true value is actually 0.5, the distribution that I'm taking from is all the way over here. So this is what Grace was saying, that if I'm taking a sample from all the way over here, it's way more unlikely that it's going to fall in that 0.05 region, or it's way more unlikely that it's going to fall anywhere near the null. That's the reason that further away gives us a higher power. Okay. If you got it, great. If you don't get it, that's okay. I'm never going to ask you it again. Sound good? Okay, let's go on. What else could the inspector do to increase power? Yeah, we said all of those. Increase the sample size, said it. Increase blocking or stratifying. Do I say? I know you said it, Jack.
I thought you were giving me like a that's the wrong answer kind of vibe.
I'm sorry I did not immediately give you feedback. Sometimes I like to see what everyone else thinks. Okay. Which term applies here? Blocking, stratifying, or both? So first question, are blocking and stratifying interchangeable?
No.
No. So then we need to remember, when do you use the term stratify, when do you use the term block?
Stratifying is when they're very similar within the block, but they're different between each other, and blocking is when like it's a lot of variance within the block, but it's the two blocks are similar.
No, but thank you. You're thinking of cluster sampling.
Oh, that's the other one.
Oh, that was the chunking. Okay, you're thinking of chunking / clustering.
They're the same thing, but blocking is for experiments.
Yes. Say it louder.
They're the same thing, but blocking is for experiments.
Blocking is for experiments. Stratifying is for surveys. They serve exactly the same purpose. Just experiment versus survey. So then the next thing we need to decide, is this a survey or is this an experiment? Don't just shout out. I said don't shout out. We can raise our hands. Ariana?
It's a survey because we're not manipulating a variable.
Correct. It's a survey, we're not imposing treatments. So in this case, we could stratify. Okay, this is the part that I'm nervous about. Part F. Suppose that the true proportion of blemished potatoes is 0.11. If alpha is 0.05, the power of the test is 0.76. Interpret this value. Oh, you all already ready? Okay, Alex.
I'll take a shot at it.
Okay.
0.76 is the probability of finding sufficient evidence that the true proportion of blemished potatoes is greater than 0.08 when this is true.
Pretty good.
Nice shot, Alex.
Pretty good. Would anybody like to change anything? Okay, the only thing I would say is that we need to add that 0.11 in. Okay, so I'm going to word the sentence differently, but it has exactly the same meaning. Given that the true proportion of blemished potatoes is 0.11. 0.76 is the probability of finding sufficient evidence to reject the null. The other way that you could say this, and I think this is how it's going to be written in your book, is the probability of finding a sample proportion large enough to reject the null. Question for you. Why do they specifically say large enough? Is it always large enough? Grace?
We wanted to find the probability that's greater than 0.08.
Correct. Greater than 0.08, so we would need our sample proportion to be bigger than 0.08. You guys are doing good so far. This is turning out to be a much better recording than my last one. Probability of a type 2 error. You should have done power is 1 minus beta, so beta should have been 0.24. Yes?
Since, do alpha and beta add up to 1, or is that
No.
not? Okay.
Okay, interpret this value. Given that the true proportion of blemished potatoes is 0.11, 0.24 of the time, the sample proportion will not be large enough to reject the null. Okay. How do we feel about power? We feel good?